Alright, so we're doing exercise 9D and we're up to question 17, which reads, suppose the probability of A equals 0.3, the probability of B equals 0.4, and the probability of A with the intersection of the complement of B equals 0.2. Find the probability of A with the union of the complement of B. So it's quite a long question and might be a little tricky for us to figure out. Immediately what we want to do, kind of just our gut reaction, is to use our addition rule because that's what we've been using throughout this exercise. But we're actually going to hold off on using this for the time being and just fill out our Venn diagram. So the first question is, can I put onto my Venn diagram the fact that I know that the probability of A equals 0.3? And I actually can't put this information down yet because the probability of A is 0.3, which applies to this entire circle. And at the time being, I don't know how it's divided up. Is this 0.3? How is it divided up into the A only and the intersection bit? And so too with B. I know that B is 0.4, but that applies to the whole circle. And I don't know how that 0.4 is going to be divided up into my B only and then into the intersection point. So I'm going to have to rely on the probability of A with the intersection of the complement of B, which is equal to 0.2. So I'm going to color in my Venn diagram to find out what A, the intersection of the complement of B, is. Okay, so let me first color in A, which is easy. A is simply going to be my circle. So I'm going to color that in like this. Next, I'm going to color in the complement of B. I'm going to color in the complement of B, which is going to be everything excluding B. So I'm going to color in everything now, excluding B. And this is going to take a bit more time. I just want to do this nice and neatly so it's clear where the intersection of A with the complement of B is going to exist. And again, these videos are just for people who might be struggling with a specific question. If you're able to do these questions without watching these videos, that's great. But if not, that's why they're here. So hopefully they're helpful to you. And I'm just trying to fill in time while I do some coloring in. This is the best part of the job, coloring in. Okay, we did it. Now, where is the intersection of A with the complement of B? And hopefully you can see it's the A only area. It doesn't include the intersection point, it's only the A only area, and we know it's going to be 0.2. So I could come over here and put in that the probability of only getting A is 0.2. And this is an important point here, that I'm putting in the probability values of each section here. Normally you don't do that, normally you put in the elements, but I'm putting in the probabilities. So I'm putting in the probability of only getting A is 0.2. And that's interesting information because I know that the entirety of the probability of A is 0.3. So that must mean that the intersection point is going to be 0.1 because 0.1 plus 0.2 is 0.3. So too, I know that the entire probability of B, the probability of getting B, is 0.4. So that must mean that the B only area is going to have a probability of 0.3. 0.3 plus 0.1 is 0.4. Perfect. Now, I should be able to figure out what my probability of A, the union of B, is. It should be 0.2 plus 0.1 is 0.3 plus 0.3 is 0.6. So I went 0.2 plus 0.1 plus 0.3 equals 0.6. And I did that just by adding up everything there. I could have also used my addition rule. So let me go for a bit of a thinner pen. The probability of A, the union of B, is going to be equal to the probability of A, which is 0.3, plus the probability of B, which is 0.4, minus the probability of the intersection of A and B, which is going to be 0.1. So what I'm going to get is 0.3 plus 0.4 is 0.7 minus 0.1, which is going to be equal to 0.6. And as you can see there, I have 0.6, 0.6, it checks out. Perfect. Now there's one part of the Venn diagram that I've left out, and it's everything not including the A and B. So the way I'm going to figure out that, because I'm dealing with probability, I know that it's going to be 1 minus the probability of A union of B. So that's going to be everything outside my two circles. And we just figured out what the probability of A, the union of B is. That's the same as 1 minus 0.6. So the probability of getting neither A nor B is going to be 0.4. So I'm going to get my thicker pen and put in 0.4. So now I've finished putting in all the values of my Venn diagram. So now I'm just going to rub everything out, because I actually haven't even answered the question yet. This was all kind of just background information to it, which is very important, but now we have to answer the question itself. So let me just quickly do this by doing this. Bang. Okay, so what does the question actually ask us to find? What we need to find is the probability of A, the union of the complement of B. So the probability of A, the union of B, the complement. Now hopefully what you can see is that we've already done the colouring in for this. A was here. The complement of B was here. So we've already coloured in A in yellow and the complement of B here. And now instead of finding the intersection point, we're finding the union. So what it's going to be is, if I could do some colouring, it's what it's going to be is A, so it's going to be 0.2 plus 0.1, so 0.3, so equals 0.3 plus 0.4 plus 0.4. So it's going to equal 0.7. That is going to be my final answer, because that's going to be the union of A with the complement of B, 0.7. Hopefully this video has clarified this question for you. If you're having any difficulty with exercise 9D or anything else we're doing at the moment in class, come talk to me. But hopefully this was helpful.